Hi guys, at the beginning of the week last week we worked on solving exponential equations. This week we're going to work on solving logarithmic equations. Um, Here are a couple strategies. Condense both sides of the equation and then use the one-to-one property if you have log on both sides of the equation. I'll show you what I mean in just a second. And another strategy, if log is only on one side of the equation, then condense the one side that you have log on and take the equation out of log form and write it in exponential form. Okay, here we go. Let's try a couple. So in number 2, this is tonight's worksheet, but you guys are going to do the odds. So I'll do a few evens here and there. The first thing we're going to do is start by condensing the right side. Let's move the squared back up over top of the 9. So we have 9 squared minus log base A of 3. All right, let's condense on the right side. So we've got log base A of x equals log base A of 81, which is 9 squared, divided by 3, because subtracting and dividing go hand in hand. So that's log base A of 81 divided by 3. Now we're going to use the one-to-one property. We call this the one-to-one property because these two things are in the same exact position. Therefore, they've got to be equal. So x has to equal 81 divided by 3, which is 27. And we know that logarithms are always positive and the base is always positive. In other words, these two numbers have to be positive numbers. So if I plug 27 in for x, will I have a positive number after the word log? And I do. All right, let's move on to the next one. In this problem, we only have log on one side of the equal sign. So we're going to condense on the left side of the equal sign. So we have log base 4 of x plus 6 times x, because adding and multiplying, we associate adding with multiplying. All right, now we're going to take it out of log form and write it in exponential form. So we only have log on one side of the equal sign. So when you have this, you just want to take it out of log form. So we have 4 squared, which is 16, equals x times x plus 6. 16 equals x squared plus 6x. Subtract 16. I know I'm going to have to factor to solve this. 0 equals x squared plus 6x minus 16. And factor x times x will give me the x squared. Two numbers that multiply together to give me a negative 16 would be positive 8 and negative 2. If I multiply my outside inside, that would give me a positive 6x in the middle. So I know it's factored correctly. So set my factors equal to 0, and I would get x equals negative 8 and x equals positive 2. So remember, after the word log, the base is positive and the number is positive. The negative 8 makes me kind of concerned. I'm going to go back to the original problem. If I plug negative 8 into the original problem where x is, you'll see I'll have log base 4 of negative 2 and log base 4 of negative 8. So negative 8 is not a good answer. That's extraneous. We're going to cross it out. And positive 2 will be fine. And it will work. We should always check our work by plugging our answers in and making sure we get the correct values. The left-hand side should always equal the right-hand side, but it does work. All right, here's another one. Notice log is only on one side of the equal sign. So we're going to take it out of log form. 2 to the first power equals x squared minus 10x plus 18. I know I'm going to have to factor again because I have a squared, so I'll subtract 2 from both sides. And I will factor, so x and x. Two numbers that multiply together give me a positive 16, so the signs have to be the same. I'm thinking negative 8 and a negative 2 multiply together give me positive 16, and outside inside would give me negative 10x. So set my factors equal to 0, I get x equals 8 and x equals 2. If I plug it back in, it does work. They're both fine. Both numbers will work. And number 22, I want to start out here. It looks very confusing. The log base 2 of the log base 4 of x equals 1. I want to start way out here, and I want to take it out of log form. Because again, I have log on one side. So take it out of log form, starting here with base 2. 2 to the first power is going to equal log base 4 of x. We want to do it again. We're going to take it out of log form again, starting here with the base. 4 squared is equal to x. So 16 equals x, and if we plug it back in, it does work. It looked like a really difficult problem and turned out to be not too bad. And number 24, I'm going to show you another one of those let z equal. We're going to use, it's called z substitution. Let's let z equal log base 2 of x. Let z equal log base 2 of x. Notice that it's here and it's here. So that would be 2z minus 7 equals 4 over z. If I want to cancel out dividing by z, I could multiply everything by z. That would give me 2z squared minus 7z equals 4. And I'll bring the 4 over. 2z squared minus 7z. I'll have to subtract 4 from both sides. Factor. We're going to be solving and finding z. So we have 2z times z gives me 2z squared. Two numbers that multiply together to give me a negative 4 could be a positive 1 times a negative 4. Outside is negative 8x z. Inside is positive 1z. And together, outside, inside, give me negative 7z, which is what we want in the middle, that middle term. That means if we set our factors equal to 0, that means z equals negative a half and z equals positive 4. Okay, now we're really not after z. We're really after x, which was the original variable. So we're really after x, but we do know z. Z is negative a half. So we have z negative a half equals log base 2 of x. So let's solve that. 2 to the negative 1/2 power is equal to x. I just took it out of log form in order to solve it. That would be 1 over 2 to the positive 1/2 power. And that would be 1 over the square root of 2 We'll multiply top and bottom by square root of 2 over square root of 2, and that will give us the square root of 2 over 2 equals x. And that is a working answer. The other answer that we got x, z equals 4, sorry. Z should have been z equaled 4. So let's come up here and we'll do the same thing. If z equaled 4, then we would have 4 equals log base 2 of x. And solve that by taking it out of log form. 2 to the 4th power equals x. And that is 16. And that also works. All right, I think I might have one more example. So in this problem, it says to solve for a. All right, let's see if we can't do that. So log base b of 4 plus, let's move the 2 back up over top. So we have log base b of a squared. And let's move this 2 over top. Log base b of n plus 1 squared. Let's condense on the left side. So we've got log base b of 4 times a squared, adding and multiplying, equals log base b of n plus 1 squared. We'll use the one-to-one property because these are in the same exact position. They've got to be equal. So we've got 4a squared is equal to n plus 1 squared. All right, if we take the square root of both sides, let's take the square root to cancel out squaring. The square root of 4 is 2. The square root of a squared is a. The square root of n plus 1 squared is n plus 1. We divide by 2, and we get a equals n plus 1 divided by 2. And that's what they asked us to solve for. They asked us to solve for a. There is a small catch. When we look back at the original problem, we would not want a to be a negative number. We would not want that to come out negative because this has to be a positive number. And so we would need to say n would have to be greater than or equal to 0. Greater than or equal to 0. If n is greater than 0, that makes this a positive fraction. That would make this a positive fraction if n is greater than 0. If n equaled 0, we would end up with 1/2. 1/2 would be fine because as long as a is a positive number. What if n is negative, even -1? -1 plus 1 is 0. 0 divided by 2 is 0. We cannot have 0 where the a is. This number has to be a positive number. So we've got a little, a minor detail that we had to deal with. We had to give the domain of n. All right, that's it. You guys have a great day and good luck on the odds.